Okay, so in all of your conversations about slope and how they, determine slope and how we find slope and how a line works when it has slope, you've graphed a few lines, I'm sure. There's a pattern that you probably have noticed when you're taking a line and you're graphing it. All right. And what you probably have noticed is that most of the equations that you see follow this form. They follow the form y is equal to mx plus b. Okay. Not all of them look exactly like this, but the majority of the lines, especially if they're linear, and really any line in general, follows this pattern. Okay. And there's a couple of things you need to know before we start using this. I'm going to show you a couple of ways that we can use it to both graph a line, find points along the line, things like that. There's a couple of things you need to remember about this form. One of the things that I'm sure you've heard before is slope. Slope is represented by this m in the equation, okay? And it's the coefficient that's attached to x. This tells you how steep the line is. It tells you the change in y in respect to x, all that good stuff. The other thing you need to know is that this b, which is kind of counterproductive because you have this y over here, but we use a variable here because y has already been taken. This is called the y-intercept, which is essentially the place where the line intersects the y-axis. Okay, so slope is steepness. Just to recap, slope is steepness, and it's more accurately described as the change in y over the change in x. Remember delta, this little triangle, delta means change. And then you also have the y-intercept, which again is that b, and that talks to you about essentially where x is equal to 0. Okay, and that's where it crosses the y-axis. Crosses the y-axis. Okay, and this is really helpful because it allows us to graph a line without having all the points there. Okay, so rather than having to evaluate an equation for as many points as we need, really, we can just graph it and know exactly where the line's going to be without having to do all the crazy math and calculations to figure out what those are. Okay, so let's say that we were given the line, let's change the color here. Let's say we were given the line y is equal to, let's do 2x plus 1. That's a good line. Okay, and let's draw our graph here. So we've been given, let's say we have the line here, and then we have this guy here, right? We can extend that if we need to. And we would like to graph it, right? We'd like to actually graph this line on this plane right here. Remember, this is our y-axis. This is our x-axis. Negative is to the left. Positive is to the right on the x-axis. And then we have up, right, is positive. And then down is negative on the y-axis. And we want to graph this, okay? Our slope is 2, right? That's our m. And then our y-intercept is 1, okay? And that's very, very helpful because it means that we know exactly where the line's going to be and we know how it's going to react once it starts at that point, okay? So the first thing you want to figure out is where is the y-intercept, okay? Where is the y-intercept? And in this case, the y-intercept is 1, which means that when x is equal to 0, okay, when x is equal to 0, that means that it's going to be at 1 on the y-axis. All right, so let's say that's 1. We'll do 2, 3, 4, 5, and we can do 1, 2, 3, 4, 5, like that. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. That's a pretty decent graph. And our y-intercept is going to be 0, which is here, and then up 1. So that puts us right there. Okay, that puts us right here on the y-axis, and it's up 1. So that's the first thing. The second thing is we need to just use the slope and plot the other points. But, 2, what does that mean, right? Well, if you remember what slope is, right? If you remember what slope is that change in y over the change in x, right? So we have this change in y over this change in x. But the problem is we have this 2 here, right? This equals 2. That's not quite what we're looking for. We're looking for a fraction with a y and an x underneath it. Now, if you remember, though, 2 is actually the same thing as 2 over 1, right? We can rewrite the fraction of 2 as 2 over 1. 1 goes into 2 twice. So this actually is our change in y over change in x. Y is a change of 2, and then x is a change of 1. So what we can do here is we can take our point, our y-intercept, and we can go towards the right and the left, and we can actually graph our line here. So I'm going to start at 2, and I'm going to go over 1, and then I'm going to go to positive 1, right? I'm going to go to positive 1 on the x-axis, and then I'm going to go up 2, 1, 2 on the y-axis, and we're going to get our point here at over 1, up 3, right? So that's our next point. And then we can go again, right? We go over 1, up 2. So that puts us at positive 2, positive 5, right there. And that's going to take us off our graph, so we don't need to go any farther here. And then we'll go left, right? It's the opposite, right? So we need to go backwards. So we're going to go down 2 and then over 1, which is right here. And then down 2 and then over 1, which is right here. And then down 2 and then over 1, which is right here. So we can graph this point, and you can see we're getting this line here, right? Let's actually connect the dots here for that. We can just use yellow. That's fine. So then if we start here and we work our way through, right, we're going to get this generally straight line right here, right? We're going to get that generally straight line right there. We'll graph this guy out a little bit, right down here. Now we have our line of y is equal to 2x plus 1. All right. And again, you can see my y-intercept is right here around the 0, 1 area. And then we've extended the line from that point in both directions. And we've got our line here. Okay. And if we were to actually take this and graph out the table, right, if we're going to chart this out, right, we could do that. So if we take x and y, and we start with, let's do just the first 3 or 4 maybe. Let's start at negative 1, 0, 1, and 2. Okay. And if we plug in negative 1, right, 2 times negative 1 just gives us negative 2, and negative 2 plus 1, right, is going to give us negative 1. So that works out. We've got negative 1, 1. 0, 2 times 0 is just 0, plus 1 is 1. So we got that worked out. That's our y-intercept, by the way. This is our y-intercept right there. And then we've got 1. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. So then we get over 1, up 3, and then over 2, up 5. So this is, in fact, our line. All right. We can do this another way with a different line. Let's do pink, and then we'll say that we have another line here. Y is equal to negative x minus 1. Okay, let's try to figure out this line. So this negative x changes things a little bit, right? Our y-intercept, our b, right? B is equal to, when x is equal to 0, it's -1. So we're really just taking that number and transferring it down here, okay? And then our slope, first of all, our slope is negative, but there's an invisible thing in front of this x. The coefficient of any variable that doesn't have one, it looks invisible, is just -1. Or, well, in this case, it's 1. In this case, it's going to be -1. If you see a variable by itself, right, if you just see something like y, this actually has a 1 in front of it because it doesn't change anything, but it does have that coefficient. So our slope for this one is actually going to be -1. Okay. And again, we can look at this delta y, delta x thing, right? If we take our delta y, delta x, right, we want to find the change in y with respect to the change in x. We rewrite this as a fraction. This is just -1/1. So our slope is going to be a change in -1, so going down and then over 1x, right? So we can see that this is going to be a negative line. So let's graph that. Our y-intercept, right? Let's use the same color. Our y-intercept is -1/0 down -1. So we get our line right here. And then we're going to go down 1 over 1. So down 1 over 1. So right about there, right? Down 1 and then over 1. And then we're going to go down 1 over 1. Again, and we're here. And then down 1 over 1, and we're here. Right? We're going to keep that pattern up. And then if we want to go backwards, we're going to go to this side, right? We just go up 1 over 1. So up 1 over 1, right? Up 1 over 1, up 1 over 1. And we're going to keep this pattern going until we're off the grid. And we get this line here that looks like this. Okay. My dots are pretty close, right? They're not perfect, but they are in fact in the right place. And that would be the line for y is equal to -x minus 1. And again, look at the sign of the m number, right? It's slope. This is slope, or m, slope and m right here. A positive slope gives me a line that goes from quadrant 3 ultimately to quadrant 1, right? Quadrant 1. And then a negative slope starts being quadrant 2 and brings me down to quadrant 4. All right, so we get a line here that goes negative if it's going from quadrant 2 to quadrant 4. If it's positive, it's going to start in the left side, bottom left, quadrant 3, and work its way up to quadrant 1, or it rises to the right. A negative slope falls to the right, okay? So that is how you're going to graph a line using slope-intercept form.